This question's off of page 191, but I'm going to use it to explain elimination method a little bit better today, okay?
Okay.
All right. So last week we focused on substitution method. And so what you would have done last week is you would have solved for y here, moved the 5x over, and then substituted into your second equation and solved it. So what we're going to do, though, is we want to use the elimination method. And I started this last Friday, and I said, okay, one of the things that you want to do in the elimination method is you want to get it so that your coefficients on two of them are additive opposites. Morning, Haley. Okay, so what I'm going to do is I'm going to take equation A and I'm going to times it by -3. So I'm going to rewrite equation A now, just below here. So I'm timesing every value here by -3. So I get -15x minus 3y equals -33. Okay? So Haley, I'm looking at an example on page 195, but I'm going to use it to explain what we're doing today, okay? So now what I do, now that I have the coefficients are what we call the additive inverses of each other, when I add them, one of the coefficients is going to disappear. So I go 2x plus -15x, which makes -13x. 3y subtract 3y is 0. And then I have 7 at -33, which is -26. So now I've eliminated one of the variables. So I can solve for x now. I divide both sides by -13, and x equals 2. So this is different than the substitution method, in that in the substitution method, I would have solved for y here and plugged it into there, and I would end up doing the same thing. But from here on in, to find the y value, I do it the exact same way I did it in the substitution method. So the two methods are only different on how you start them. So now I'm going to plug 2 in for x and solve for y. So my solution, where those two lines are going to intersect, are at 2 and 1. Okay? So the elimination method is and can be pretty slick, actually, compared to, there's a lot less work compared to the substitution method in some of these cases. All right? So now let's go to page 195, and let's do the question that they have on page 195 now, which is the one I looked at last week. Okay, so it says 3x plus 2y equals 2. And the second equation has the x and the y on opposite sides. So I'm going to put them both on the same side. So I'm going to go 4x plus 5y is equal to 12. Okay. So now I want to line this up. I want to have it so that two of the coefficients, either the y's and the x's, have numbers, the coefficients, the numbers in front of the variables, so the number in front of the x or the number in front of the y, so that they are, when I add them, they're going to get me a 0. So I have to multiply one or both of the equations to match this up. So what I'm going to do is I'm going to use the x's now. So I'm going to multiply 3x by -4. So this whole thing I'm going to times by -4. And I'm going to times this whole thing by 3. Now what that's going to do is that's going to make the x's the additive inverses of each other. So they're going to cancel out. So watch what happens here. So in equation A, I times everything by -4. I get negative 12x, negative 8y, and negative 8. Now in the B part, I'm going to multiply everything by 3. That's going to give me 12x plus 15y equals 36. So again, in the elimination method, my goal, my intended goal, is to get the variables so that I can cancel one of them out. In order to cancel them out, I have to have the number in front of them be opposites. So like negative 12 plus 12, negative 4 plus 4, negative 3 plus 3. Okay? Now I can add them together. That gives me 0. This gives me 7y. This gives me 28. Y is equal to 4. So now I have to use one of the two equations to find out what x equals. So I go 3x plus 2 times 4 equals 2. 3x plus 8 equals 2. 3x equals negative 6. X equals negative 2. So my solution, where these two lines intersect, is negative 2 and 4. Now, if you have been using Desmos, the graphing app that I suggested you use a couple weeks ago, if you're using it, you can graph these two and find out what the intersection point is going to be to check your answer. It would only take you another 30 seconds to do that, and you would guarantee that you can get it right each time. However, you do need to know both the substitution and the elimination method. Okay? So we're going to try a word problem. This is where it gets a little more complicated because now you have to write out the equations for it. All right? So this will be the hard part. All right. The Fête au Village is an annual festival in Legal, Alberta to celebrate the French culture of Legal's pioneers. Two popular events are the tug-of-war and the demolition derby. A tug-of-war consists of 8 people. The entry fee is $20 per team. Each demolition derby has 2 members. The entry fee is $100 per team. If a total of 94 people enter both events, and $1,660 is collected in fees, how many teams are entered in each event? So we need to, again, let's look at this. So what is X going to represent and what does Y represent? Well, X is going to represent the teams in the tug of war. And Y is going to represent the teams in the demolition derby. So that's the number of teams. Now we know that we have a total of 94 people. All right. The tug of war teams have 8 persons per team. The demolition derby has 2 people per team. So to get the number of people, I go A is equal to 8x plus 2y, and that should equal a total of 94 people. Like I said, this is not going to be the easy part. This will be the part that you're going to find a little bit more difficult. So if I have one team of tug of war, that's 8 people. If I have 2 teams of tug of war, that's 16 people. If I have one demolition team, that's 2 people. If I have 2, that's 4 people. So I multiply the number 8 and 2 by each to get me the total, depending on the number of teams. Now in B, the tug of war, it costs $20 per team. and the demolition derby costs $100 per team, and the total is $1,660. All right. So now we want to attempt to use the elimination method here. Okay. So to use the elimination method, all right, I need to match these up so that one of them is the additive opposite of the other. So the 8 and 20, they don't go into each other very well, but 2 goes into 150 times. So I'm going to times my top guy here by -50, because that's going to make that -100, and when I add it to 100, that's going to give me 0. I will have eliminated the y. All right, so let's rewrite this now. A. So times it by -50. That's -400x. Subtract 100y equals, so 94 times 50. -4,700. And now I add them together. This makes -380x. This is 0, which is what we wanted. And now I add these together. And then I have to divide by 380 eventually. Divided by 380. That means I have 8 tug-of-war teams. 8 tug-of-war teams. All right, so now I need to find out how many demolition teams I have. So I go 8 times 8 plus 2y, and that has to equal 94. So 64 plus 2y equals 94. 2y equals 30. Y is equal to 15. So I have 8 tug-of-war teams and 15 demolition teams. And you know what? I'm going to check my solution to see if I got it right. So I'm going to take the second guy, and I'm going to times it by my values. So I'm going to take 20 times 8. And 15 times 100. And I add those together. And I know I've got it right. Again, you can check your solution by putting it into one of the equations, the one I didn't use to solve, to make sure it's right. Or you could graph it using your Desmos calculator. Okay. All right, so this is fairly advanced because 1, you have to write these out. 2, numbers were big, knowing how to do it. So we're going to go now to your assignment, and let's pick some of these and let's do them slowly, and we'll work through them. So let's look at 1. So on page 197, I'm going to go through the first with you. So I've got A, excuse me, B, okay. So the elimination method, the first thing I need to know is that I have to have them in the same order. So it's got to be X, Y, and then the constant on the right side is usually how you want to do it. All right. The second thing is I want to make sure that on one of the variables that in equation A and equation B, when I add them together, they're going to cancel out. So looking at this guy right now, I have a -1 on the Y and a +1 on the Y. So if I were to add those together, I would get 0y. That's what I want. So I'm going to add these two equations together. So 2x and 5x make 7x. Negative y and y make 0, and that's equal to negative 7. Now all I do is solve for x, divide by 7, x equals negative 1. Now I have to find out what y is. So I'm going to use equation B. 5 times negative 1, add y equals negative 2. Negative 5 plus y equals negative 2. Add 5, y is equal to 3. These guys intersect at negative 1 and 3. This is what we call the elimination method. Okay? All right. Let's do the second one now. The second one is 4x plus 2y. Okay, so the first thing that I notice is when I'm looking at the coefficients, so that's the number that's in front of the variables. I have a plus 4x and a plus 4x. So what I want to do then is I'm going to change 1 to a negative 4x. So I'm going to multiply one of the two equations by negative 1. Doesn't matter which one. But what I have to do is I have to do it to all of the pieces of that equation. So I'm going to multiply equation A by negative 1. So now I'm going to go negative 4x minus 2y equals negative 6. So what I did is I multiplied that by negative 1, that by negative 1, and that by negative 1. Now I add these two equations together. I get 0 minus 5y equals minus 5. Divide by negative 5, and I get y equals 1. And again, I do the same thing I would have done with substitution. Put it back into the equation. And solve. So I've got 1 and 1. Okay. So the key to the elimination method is lining up one of the variables so that when I add them, these two values will add to 0. Getting rid of it so I can solve for one of the unknowns. Okay, so let's look at the third one now. So I have A is 3x plus 7y equals 17. And B is 2x minus 3y equals negative 4. Now again, I'm explaining this to you in great detail because in grade 11, we do this with quadratic functions, and this is the best method to use if I'm using quadratic functions. So I want to really get a good grasp. Okay, so looking at it, I have nothing that I can add, because if I add this, I'm not going to get rid of one of my variables. So I have to change one or both of the equations so that when I add them, I get rid of a variable. Well, I got a 3x here and a 2x here. I know that if I multiply this by 2 and this by 3, I'm going to get them both to 6. So that's one way to get the numbers to match. And I'm going to also make one of them a negative. So what I'm going to do is I'm going to times this top one by -2, and I'm going to times this bottom one by 3. Okay, that's going to give me a -6 and a +6 so that the x's are going to cancel. So I rewrite it now. A minus 6x minus 14y equals minus 34. Times by -2, times by -2, times by -2. B, times everything by 3. 6x minus 9y equals -12. Now, I add them together. Minus 6x and 6x equals 0. This is minus 23y. And this is minus 46. So now that I've added them together, I got rid of my x's. Now I'm left with just a y. Y equals 2. Okay? Now I got to find out what x is, where they intersect. So 3x plus 7 times 2 equals 17. 3x plus 14 equals 17. 3x equals 3. X is equal to 1, 1, and 2. Again, I can graph it, or I can substitute it back into this equation here in order to solve it. So there is my solution. Okay. All right. So that pretty much takes care of the start of 9.2 for you. All right. So if you could complete to the end of question 5 for tomorrow, and then just leave the word problems for tomorrow. I'll go through 1 or 2 of the word problems with you to get you started tomorrow, and then we'll go through the rest. Any questions, girls? No? Hey, Haley, you're doing okay?
Yeah.
All right. Emma, okay?
Yeah, I'm good.
Okay. So I will leave you with that today. And tomorrow morning, I will go through questions 1 to 5 with you. And then we'll do some of the work with the problems. Does that sound okay?
Yes.
Good to see you on here today, Haley. You doing all right with the math?
Yeah.
Perfect. Right on. Okay. That's all I have for you today, girls. Enjoy the rest of your day, and we'll get back at this tomorrow morning, okay?
Thank you.
Okay. Have a good day.
Bye.
Bye.